Welcome to another edition of BASTA TV from the BASTA 2014 in Darmstadt. With me is Udi Dahan. He's working with Particular.
That's right.
Maybe you can explain our customers a bit what your role is in there, because you call yourself a software simplicist.
Right. Right.
Mm-hmm.
So for a large number of years, I was working as a consultant, and during that time frame, I adopted a label that was given to me called the software simplist, and primarily because my focus has historically always been and kind of continued up until today, how do I make software simpler? Primarily from the focus of developers. The whole UI aspects, how to create a better looking, more intuitive user interface, that's not me. That's not my core skill set. I'm sort of deep in the code. But after many years of seeing overly complex software, I said, you don't need all this. You could achieve the same results with 1/10 of the code. That's historically been my focus. During that time frame of consulting, I saw that a lot of my customers were running into similar problems around reliability, maintainability, scalability type problems. And I started explaining to them how to stitch together various pieces of technology, queuing systems, databases, etc., to solve those types of problems. And after a while, I began to realize that instead of me just repeating the same recommendation over and over again, it would be better if I took my own advice and put this stuff together into a packaged type of library so that people could use it directly without having to reinvent the wheel each time. That grew into an open source framework called N-Service-Bus. And after several years of running with N-Service-Bus as an open source framework, I created a company around it, calling ourselves now Particular Software. So I head up Particular Software, and I'm the founder of the original code base in N-Service-Bus. But it's really grown beyond me now. There's 10 developers that are working on that code base every single day, and I don't always know exactly what's going on in the internals anymore, which is unfortunate because I really enjoy working with the code. But I still stay close enough to the code, but let's call it that mantra of simplicity that I've always carried with me is really entrenched into how we design the frameworks that we provide our customers, as well as to their experience in using our tools. We try to make it as simple and straightforward and reliable and maintainable as possible. Okay.
Yeah, we could see that you're still quite firm in coding, because you just gave a keynote here at the BASTA about the fourth dimension of programming, and to me this fourth dimension has two aspects. One aspect is that what's in the foreground for you was time. Maybe you give us just a short abstract on what this time aspect means for the developer.
Right.
And then we're going to talk about the second aspect.
Okay. So one of the elements that I talk about in that keynote about programming in the fourth dimension is requirements that look simple at face value with regards to time. A lot of times we get requirements that say, calculate the difference between 2 points in time between when a customer does this and a customer does that, or a user does this action and then some other user performs another action. We have logic around that. The challenges there that I've seen companies go through is that these requirements that seem simple and the first implementation usually does work. It's the longer term maintainability aspects that become a problem, meaning that when the requirements change, sometimes just changing the implementation causes these side effects that customers or users that kind of fall into that transition period between version 1 and version 2 of the system, all of a sudden get weird behaviors where the behavior that they expected, which was based on the original set of rules, now is different with the new set of rules. In some cases, that's actually a legal problem because there are regulations that state that if you made a promise to a customer at a certain point in time, you have to fulfill that promise. And if you don't, then you could end up being sued or something. It kind of depends on the legislation. So explaining to developers that they will be aware that there is this sort of problem out there, and that the traditional simple implementation sometimes isn't enough, and then describing other patterns that use queuing systems, service buses, in order to solve those types of problems in still a fairly simple coded way. It's not that you have to write 10 times as much code, but you just sort of structure the code a little bit differently.
Yeah, and that's on the technological aspects, and sometimes it's a very small change for the developer, but it might have a big impact on the business of the company. And that's the second aspect, what I think of the fourth dimension we're talking about is, and what we should talk about. You mentioned quite often right now the customer. Yeah, there's a developer who's doing something, and it has an impact on the customer because the company made a promise to the customer to fulfill something.
Right.
The requirements are coming from the business to the developer, but in the end, the action of the developer is responsible for the outcome for the customer and the company. To me, that shifts a bit the position of the developer nowadays. Lots of developers are now really responsible for the business value and the business models of their companies. Is this a new type of developing that people have to grow accustomed with?
Well, I think that there are, it's called definitely in the consumer space, social networks kind of being the most obvious ones, where we're seeing a relatively small group of developers able to create something that has a very meaningful impact to hundreds of millions of people's lives. That's a relatively new phenomenon that hasn't happened for a long time. Together with, let's call it, broad society awareness that this is happening. So not only are the developers aware that this is happening, but then users and the press and the media, everybody kind of becomes aware that, wow, if we take the recent WhatsApp example, 50 developers, 400 million users. That's that sort of ratio didn't ever really exist. Now, in not only in those types of companies, but in many consumer-facing companies, a lot of the best ideas for the business actually come from developers, the ones that understand the behavior of the system the deepest. They're the ones that can say, there's a real opportunity here to do something new and valuable that maybe the business didn't realize. The whole big data revolution, if you will, has come from mostly people with an engineering background saying, there's patterns to be found here. There's business value that we can get out of all of these vast quantities of information. So even if we take a generation back from big data, and before that was called data mining or data warehouses or whatever, for the most part that was driven by people with a much more engineering perspective saying, there's something here, I can sense it, that has some meaningful business value, and surface those ideas to business stakeholders and to do a proof of concept to actually show, here's what we're able to find through this, that ends up having a very big impact. So I definitely agree with you that we're sort of on a growing trend where developers are in a much more powerful position to have far-reaching impacts on the business, to go to the point of suggesting new requirements and new features that in many cases are disruptive and have that sort of big impact. How broadly that occurs across the industry, I'd say in the consumer space, we're seeing it a lot. Financial services, where the users themselves are often, I'm not sure if I'd use the word technical, but they're very, very data-centric also as well. I'd say that if you move into more traditional industries, like manufacturing or logistics, then maybe a little bit less. But in this interconnected world that we're in, there's people in one industry are watching what others are doing and saying, that's really interesting. Maybe we can do the same sort of thing. But I'd say the power dynamic between developers and the business stakeholders, that's happening, the shift is occurring in more verticals, not yet all of them.
And what does it mean for the architecture of the system or the systems itself? I mean, there are lots of services now around. As you said, it's a connected world. It's connected by services. Messages are important. Different silos have to be broken up. And how does it affect the system itself? What kind of aspect is important to regard?
Well, architecture has always been something that's kind of been ill-defined, where design stops and architecture begins, and then when architecture kind of ends and business analysis begins, there's kind of these two gray areas on either side. Personally, in my consulting practice, I've always put a great emphasis on the business analysis side of things. I think that there's a great deal of opportunities for people that are able to understand the fundamentals of the business domain well, and are able to do that, the correct type of modeling, to divide up the problem the right way. That ends up having really major long-term benefits for the quality of the code and the sustainability of the design that ultimately sits in that architecture. It's something that I've been spending the past, 7 or 8 years of my life traveling the world teaching people, is how to do this type of business analysis, what sort of rules to follow, what things to watch out for. The fact that things get more interconnected, in essence, or the way that I view that, is that while on the technological side of things it means that we have more tools at our disposal to implement things, on the business analysis side of things, I think that there's an even faster growth on the size of the problems that we're tasked with solving. So, I mean, if you look in the past 10 years, how many new tools we've gotten versus the size of the systems that we're building, I've seen much stronger exponential growth around the sizes of the systems that people are building. It's I want to integrate with anything, everywhere, all the time, performing business logic on more data in real time, where the business logic itself is much more complex than we've done before. And I want that all delivered at the same rate as what you delivered last year, 5 years ago. So, the tools are kind of developing, but I see that the appetite for the size and the complexity of the system is just growing that much faster. And I don't think that there's been much time given to architects as a whole to perform this transition, to skill themselves in the new types of tasks that they're handling. But nobody's waiting. I mean, the wheel of progress is continuing to turn.
Yeah, and it seems to turn faster. And you mentioned it, the systems are growing, they're getting more complex. And now there are people saying we have to build systems which are resilient, so that we as humans do not really act when something fails. These concepts are quite new. And they are powered still by the cloud, because now the customers and the partners and the business demands or expects that everything works every second. How far is that problem acknowledged in the industry? What do you think?
So the idea of resilience, I think is not actually that new. It's just being spread into more vertical domains. I mean, if you're talking about medical devices, the whole idea of resilience was always a very big deal over there. Number one thing, do not kill the patient, right? But it's kind of been spreading, again, with the size of the system and the business impact of the system. Together with that, you want the system that's more safe, it's more resilient in the face of failures. Based on what we said before, with more interconnection points and more data, making a system that's resilient is harder than when it was just, you had your web server talking to your database and that was it. And I don't want to say it was easy to make that resilient, but at least your problem had very well specified boundaries. The more you interconnect, the more data sources that you have, the more mobile that your users are, the more difficult that becomes. But I'd say resilience, it's nobody knows that a system needs to be resilient until they find out that it's not resilient enough. So the baseline assumption is it's going to work because, well, when I ran it on my machine, everything worked fine. It's kind of like security. And someone said, we have this belief that everything's okay until something bad happens, and then we're kind of running around after the fact to try to clean it up and to button it down. So,
but today we do not have the time to run behind the problem.
Right. Now the thing about the cloud, it's interesting that you mentioned it, is that while the cloud gives us more flexibility and more resources at our disposal, a lot of the resources that are running in the cloud are actually less resilient, less reliable at sort of a single unit than what we would have had in our data centers in the past. So it's much more likely to have a point level failure on a machine running in the cloud than in your own data center. The way that the cloud promises to solve that is saying, well, you're going to have to program slightly differently. I don't think that enough people really understand that shift, that moving to the cloud, while it gives you certain infrastructural benefits, it takes away certain guarantees that you might have been able to run with when you were running on premise. And that actually leads to systems that are less resilient because they're in the cloud. And only when things start to fail that people are like, oh my God, I didn't realize that we didn't have a transaction that behaves the same way in the cloud as it behaved in our regular system. I didn't realize that we get throttled by the cloud provider in this sort of way, so things end up timing out more frequently. And so to say that the cloud helps, well, it cuts both ways. It provides some tools, but it takes away some other tools, and it takes time for people to re-architect their system for that. But I don't think the demands for resilience are going away. It's just that there's a transition that it takes for us as an industry to codify new practices around, okay, this is how systems should be built for solving these sorts of problems.
Yeah. So it seems that progress doesn't make it easier or simpler for developers. Based on your experience, what advice give you a developer to open his mind to this new situation and start to find his way to make it simple for him to get the results he wants to?
So, advice for developers. Well, I guess I'd say the advice that I give developers is advice many people have been giving them is get out of your bubble of assuming that everything that you need to know will be provided for you by your company. In other words, if your company's not using technology X, then you can ignore technology X. That would sort of be the baseline and say, assume that the world is going to change and that you are going to be impacted by it, and that nobody in your company is going to prepare you for it when it happens. So you're ultimately responsible for your destiny, whether it's going to conferences or reading books or reading blogs, go beyond just the I've got a problem that I need to solve right now at work. How do I solve it? Take a more broad, how do I find out what's going on in the industry? Read about functional programming languages, even if you're not using one right now. It will probably make you a better developer because it gets your brain to think differently. If you haven't played with any type of NoSQL database, take one and start playing with it. It's great if you have a company that is open to you doing this on their time or potentially using it on small-scale projects for you to upskill yourself on these new technologies. But even if they don't, you don't want to end up 5 years from now, 10 years from now, realizing that you are now an equivalent of a COBOL programmer. That the industry's moved on, and you're stuck in the past. That's not, I mean, COBOL programmers today, they're still making very good money. I don't want to disparage them. And there's a smaller and smaller number of people that actually know COBOL well enough to be able to maintain the massive code bases that are out there. So, just from let's call it a supply and demand perspective, COBOL is actually a very good place to be from a purely financial perspective, because they're big, gigantic banks and insurance companies that have trillions of dollars dependent on this code base, and there's a very small quantity of people that know how to maintain it. You could probably write your own ticket. That being said, most developers would rather slit their wrists than actually program in COBOL. But again, I'd say if you put the financial thing aside and just say for you to keep yourself relevant and interesting, read, go to conferences, talk to other developers, meetups, find out what's going on, play with the technology, and I guess I'd say it's kind of like learning a new verbal language. It makes your mind more flexible and adaptable to the changes that are going to be coming.
Okay, thank you very much for these insights, Udi, and being with us.